As it's been said in the problem, it turns out that if a car is moving around a circle, then it is possible to curve the road to make it banked at a certain angle, beta, so that no friction is required to keep the car on the track if the car is traveling with a certain velocity, v. So the question of the problem, what is this angle beta for a given velocity v of the car and the radius of the circular track r? Well, to answer on that question, as usual, we start with the free body diagram. So the forces acting on the car are, there is an mg force pointing downwards. Remember, there is no friction, so there is only normal acting from the surface. And because the track is backed at an angle of beta, the normal should be perpendicular to that surface. So this is your normal n. Now remember, if this angle here is beta, then this angle here is also beta. The car is moving on a circular trajectory, so it has a centripetal acceleration towards the center. So this is our centripetal acceleration AC. So now we need to find out what should this angle beta be. Well, we have the free body diagram, so we can write the Newton's second law here. And let's say that the upwards direction is positive y, and this direction is x. So let's look at the y direction first. Now let's write down the Newton's second law for y and x axis. Let's start with the y axis. So for the y axis, we have y component of n, which is n times cosine beta, and it's pointing upwards, so it goes with a plus. So n cosine beta. And then mg, it's pointing downwards, so it goes with the negative sign, equals mass times acceleration in the y direction, and in the y direction the acceleration is 0. So this is the Newton's second law for the y-axis. Now for the x-axis, we have normal times sine of beta, and it goes with a positive sign, as it's pointing in the positive x direction, so n sine beta. And mg has no x component. So this is equal to mass times acceleration AC. Or we can say that this is equal to m times v squared over r. So we have these two equations. So let's write them down here. So we have n sine beta equals mv squared over r. And from this one, we can see that this is equal to n cosine beta equals mg. So we can now divide this upper one by the lower one. So if we do that, then on this side we get sine over cosine, so this is tangent beta. N will cancel, and then here m will cancel, and you get v squared over rg. And so you can now calculate for beta. So beta is equal to tangent inverse of v squared over rg. So this is the angle that is required for the car to travel on the circular track without any need for friction. So it can travel on the icy surface.